All right, so probably we've forgotten what you can and can't do with these, right? Because it's been a while since we've done negative exponents. So to do number 7c on the chapter 9 mastery, which has 36x to the minus 2 minus 3x to the minus 1 minus 18, all over 12x to the minus 2 minus 25x to the minus 1 plus 12, I first have to remember negative exponents, right? So x to the minus 2 is 1 over x squared, and x to the minus 1 is 1 over x. But how do you implement this information?
It'd be 36 over x squared.
Ah, okay,
Because
so
you're only affecting the x, not the whole number.
yeah, so this is 36 times 1 over x squared, right? Okay, see that? That's 36 over 1 times 1 over x squared, right? And then we're subtracting 3 over 1 times
1 over x.
1 over x. And then we're subtracting 18 from that. And then on the bottom here, we've got 12 over 1 times 1 over x squared, right? Minus 25 over 1, good. Times
1 over x.
1 over x. And then we've got plus 12, right? Maybe it'd be better if I put 18 and 12 also over 1. Cool? Totally. Okay, so let me multiply all my fractions together. So what do you got on the first one once you multiply?
36 over x squared.
Okay, so you got 36 over x squared minus 3 over x minus 18 over 1 all over 12 over x squared minus 25 over x plus 12 over 1. Okay, now what do you think?
Find the common bottom on all of them.
Yeah, so on the top, what's the common bottom?
X squared.
So on the top, the common bottom is x squared. On the bottom, the common bottom is
X squared.
also x squared. So let me throw those in here in blue. What's this first guy, 36 over x squared? What's that need to get an x
Nothing.
squared on the bottom?
Nothing.
Nothing. What's the 3 over x need?
X.
X, top and bottom, right? What's the 18 need?
X squared.
X squared, top and bottom. And on the bottom here, what's the 12 over x squared need?
Nothing.
Nothing. What's the 25 over x? What's that need? An x, top and bottom. And the 12, what's that need?
X squared.
X squared, top and bottom. So in my next step here, I've got
36 x squared
36.
over x squared.
It's all going to be over x squared, right? And then there should be an even bigger fraction part here for the bottom.
Then it's going to be a minus 3x. And plus 18x squared.
Plus
Negative 18.
minus 18x squared. And then that's all divided by
12. All
12 minus 25x plus 12x squared over
x squared.
x squared,
And then
right? And remember here with this long fraction bar, I'm thinking divided by, right?
My mind. So you're going to flip the
Yeah, so I can flip this thing. So I'm going to get
36
36 minus 3x minus 18x squared over x squared times
x squared
x squared over
12 minus 25x plus
12 minus 25x minus plus 12x squared.
Do you think we could rewrite that in standard form?
What do you mean? Oh, right, the other order.
Yeah.
Yeah, that would be a real good idea, right? What else can I do here other than rearrange? You see that? That's a onesie. So after I do a onesie and rewrite, maybe.
It's gonna be negative 18 x squared.
So I got negative 18x squared
Minus 3x plus 36.
Plus 36.
minus 3x plus 36 all over
12x squared
12x squared minus 25x
plus 12.
plus 12.
Probably should
Factor
factor out the 3 on the top. You can't factor the bottom, but you can factor out.
Okay, I can't factor anything just pulled out of the bottom, right? But out of the top I can pull a 3.
Negative 3.
And I would advise for a negative 3. Okay, so I'm going to get negative 3 times on the top, what do you got?
6x squared minus
Plus x
minus 12.
minus 12. And on the bottom here I've got same stuff, 12x squared minus 25x plus 12. And now what are you hoping for?
Hopefully I can factor out.
Yeah,
You're
see if
gonna
you can
have
find
to
some
see.
onesies. So I'm going to have to AC factor some stuff, right? So to AC factor the top, what am I looking at?
It's going to be 3x minus 4
2x plus
times 2x plus 3.
Where'd you get that?
Just
Just
looking at
looking at it.
I have it down here. I did this one.
Oh, you did this one already. Okay, so I'm looking for two numbers that multiply to 72 and add to 1. What are those?
8 and 9.
8 and 9, right? Gotta be. So I got 6x squared plus 9x minus 8x minus 12. And then I should what?
Factor by grouping.
Yeah, so I can pull a 3x out and a, what can I get out of it?
Minus
4.
Minus 4 looks like. So I'll get, after I pull a 3x out of the first two,
2x plus 6x.
get a 2x plus 3. And out of the second bit, what am I left with?
2x plus
Hopefully a 2x plus 3, right? Okay, so that I know that the top, oops, wrong marker. I know that the top is negative 3 times 3x minus 4 times 2x plus 3. Good with that? Okay, now I need to AC the bottom.
Something multiplies that to 144 and adds to 25.
Uh-oh. Okay, so I need multiplies to 144 and adds to 25. Multiply to 144, add to 25.
This could be a 9 and 16.
So you're going to end up fiddling with this for a little bit, right? So 144, I might notice, is 2 times 2, maybe 12 times 12. How about that? So that's 4 times 4 times 3 times 3. So there's a whole mess of 2's and some 3's. So are 12 and 12 going to work?
No.
Get to 24, right? Which is close, but not enough. So then you might try some more.
It's a 9 and 16.
Eventually you'll probably happen across 9 and 16, which works. So what do you do with that? Yeah, rewrite the middle. So I got 12x squared minus 16x minus 9x plus 12. And then I need to factor by grouping. So I'm going to get, let's see, out of the first two I can get a 4x, and I'll be left with, see you later, 3x minus 4. And then out of the second bit I can get a
Negative 3.
-3, and you'll be left with a 3x minus 4 again. And so I can rewrite the bottom as
X minus 3, 3x minus
4x minus 3 times 3x minus 4. And the whole point of this was to 1z the 3x minus 4, right? And so I'm left with
-3 times 2x plus 3
-3 times 2x plus 3 over 4x minus 3. Cool? Whoop. Okay, there's a small trick here that can make your life a little easier. If you see negative powers, right? Like here, there's negative powers all through. If I pick the biggest negative power and multiply top and bottom by that, but with a positive, you guys see I've got a 1z here, right? If I distribute this through, it'll get me to that step there. So it does not get you to the end, but it will avoid some common bottom futzing. Is it easier? I don't know. You got to remember this trick. And you got to pull it off, right?
Oh, it cancels out the negatives.
Yeah, this is that same thought about multiplied through by the common bottom, right?
Yeah, okay, so it takes out the negative ones and puts positive ones.
When does that trick work?
When you've got negative exponents kind of scattered through the sum, and more negative exponents on the bottom of the same thing, right? So you've got a fraction made with negative exponents. You can multiply through by the biggest power you see, but positive, and that'll flip them all to positive powers.
But if instead of -1, for example, those are positives, would you want to bother?
Yeah, so if all of these powers were positive,
No, just half of them, like if the negative.
yeah,
one
you might
is,
still think this is a good idea. In that case, you would end up with cubics and you wouldn't be able to solve this anyway.
Oh, okay.
Cool? Questions, things? Okay.